Good morning. Myself Vanita JC, lecturer in Civil Engineering Department, Government Polytechnic, Nagmangla, Mandya. Department of Collegiate and Technical Education has introduced the LMS program for the Polytechnic students. As part of the LMS program, today I am giving the lecturer on deep foundations concept. Coming under Construction Technology course and course code 15 CE 34T for third semester civil engineering students. Before discussing deep foundations, on first we shall recall what is foundations and types. Foundation is a structure used to transmit load from superstructure to substructures, and foundation which support the superstructures. These foundation is preferred based on soil conditions. These foundations are classified as two types: shallow foundation and deep foundations. And foundation is a structure used to transmit the load from superstructure to substructures. Foundations which supports the superstructures. These foundations is provided based on soil conditions. These foundations are classified into two types. So first one is the deep foundations and shallow foundations. According to in bearing capacity of soil is good, we can adopt shallow foundations. In shallow foundation, depth of foundation is equal to or less than its width. Suppose in site, if we foundations more soft soil, that is the depth of foundation is more, or any presence of water table near ground, and as if load is more, we preferred a deep foundations because we could not provide shallow foundation. In such cases, shallow foundations is further classified into spread foundations, combined foundations, mat or raft foundation, grillage foundations, eccentrically loaded foundations, strap foundations or cantilever footing, strap footings or cantilever footing, stepped foundations. So first, deep foundations. In deep foundations, we provide foundations of depth is more than the width of foundations. Okay, deep foundation. In deep foundations, we provide depth of foundation is more than width of foundations. Deep foundations again classified into two types. So first is the file foundation, second one is the well or cushion foundations. And foundations, if the depth of foundation is greater than its width, it is termed as deep foundations. And deep foundation is further classified into two types. So first is the file foundation, second is the well or cushion foundations. And file foundations. Files are used for foundations for bridges, trusses, etc. Structures have to carry more load. So in the figure, you see files are driven to the depth of high density soil. So figure shows the lower, medium and high density. So the low density soil has less bearing capacity than high density soil. To resist a load acting on file, we have to driven file till it reach high density soil. So figure shows the group of files with cap. These file caps means as a mass concrete structures contain more files embedded on it. These used to transmit load structures to high bearing strata. These through files. These files distribute load buildings or structures into the ground. And so file foundations. So figure shows the file foundation. These will be provided below the ground where the soil is soft. Here depth provide more than width. So if file foundation generally D is greater than 3D, the file can be made of any materials, that is cement, concrete, timber, steel, sand, composite files. So these are chosen based on structures usages. For important structures, we preferred steel files. So for unimportant structures, we preferred uh, timber. So in our diploma syllabus, we have to study file foundations only. Okay, and next is the next these files foundations is necessaries. That means file foundations necessaries of file foundations. So first, load coming from the structures is heavy and non-uniform. In that situations we preferred file foundations. Inside, suppose the presence of water table so high. Due to the presence of this water table could not withstand more load acting on it. So shallow foundations could not provide in such cases. We have to prefer deep foundations. Load is heavy and non-uniform structures. We preferred file foundations. Raft foundations are costly or adopted that is impossible due to the local difficulties. In such situations, file foundations is preferred. During heavy inflow of capillary water, where it is not possible to maintain foundation trenches because of presence of the water could not trench dry. One, it is not possible to timber the excavate trench. The upper layer of the soil is compressible. The upper layer of the soil compressible and waterlogged. In such cases, compressible soils cause settlement of structures. Due to this settlement, cracks appears on superstructures. The topsoil has poor bearing capacity. So in that situations we prefer file foundations. Files are also provided so when there is large fluctuations in subsoil water level, and also provided in structures where it is situated on the seashores or river bed. So in some places, if a canal or that is deep drainage lines exist in near foundations, these files are provided because these files are slender. It takes less space for construction and it can more load. And so these are the necessities of the file foundations. So next, soil, that is expensive soil cause cracks to the structures. So in this slide shows the types of slides. So types of slides is classified according to function, according to material, and that is composite compositions. According to based the purpose of functions, it is classified into bearing files, friction files, sheet files, fender files, anchor files, batter files, compaction files, and screw files. So according to function, it is classified into bearing files, friction files, sheet files, fender files, and anchor files, and compaction files, and screw files. So next, bearing files. In this figure, bearing files are arranged or laid on hard incompressible layer. So in previous slides, I explained here soft soil. Soft soil has less bearing capacity than hard compressible layers. So these files are act as column or piers. We provide columns to the buildings and which gives the support to the superstructures, and piers is it is constructed in the it is nothing but a intermediate support of the bridge to support the slab on it. These files are also called end bearing files because lower end of the files can withstand load acting on it, and it also act as medium to transmit superstructure load on or strata. It does not have considerable depth because it has to driven till it reach hard strata. And so figure shows the bearing files. So upper layer of the soil, it is a soft soil and compressible soil, and it will be reach the hard strata, that is hard incompressible layer. And next is the friction files. So this slide shows the friction files. So in some cases we could not provide bearing files. That means below the ground level more soft soil present where it is difficulty to get hard strata. In those situations, end bearing files depth increases and its cost of construction is also increases. So we have to provide alternate files, that is friction files. Here load is resisted by the files through friction developed between soil and surface of files. These files are driven till skin friction developed at sides of files is equal to the load coming on the files. And so figure shows the friction files. So load from superstructures, and the frictional skin friction will be that is soil, soft soil with increases the stiffness as the depth increases, and friction force will be act. So next slide shows the difference between the bearing files and friction files. So in case bearing files, it is also called as end bearing files. In friction files, it is called as a skin friction files. So that is another difference in this bearing load is resisted by the lower end and files which is rest on hard strata, whereas in that is skin friction files, load resisted by the friction along the surface of files. And bearing files can be chosen if hard strata is available because the loose soil of low bearing capacity. So whereas friction files provided over the cohesive soil with loose bearing capacity. Bearing files can provided if water presence in soil because the presence of water does not affect that is functions of bearing files, whereas friction files cannot provided in presence of water because water reduced friction developed on surface. So friction files should not abide in presence of water. And next, that is figure shows the difference, that is first one is shows the end bearing file, second figure shows the friction files. First one is bearing files and second one is the friction files. It is shown in figure. Bearing files is driven below the hard strata. Friction files does not driven of hard strata because no hard strata present in friction files. Both files driven in soft soil. In end bearing lower end resistance load on it, whereas in friction files frictional force developed on surface of files resist load acting on it. And load Q is load acting on both files. In friction sites, stiffness of file increases as its depth increases in soft soil. These frictions as to driven till friction resistance developed in sufficient to resist load acting on it. So next, the types of sheet files. Next is the type of sheet file. These sheet files are essential in some situations. Let's see where these sheet files are adopted. So these sheet files are required to present leakage of fine materials and water, that is fine materials and water. These are used in retaining wall constructions, in ducts and wharf and other marine structures. These sheet files protect structures from shocks and vibrations. These protect the river banks from erosion. These sheet files retain sites of foundation trenches. These files are used to confine the soil to increase bearing capacity of soil. These files are used to isolate foundations for adjacent soil. And next figure shows the sheet files which is provided as a retaining wall in beaches. So these sheet files are made up of steel. So which is driven into the ground to prevent backfill enter into the excavation portion. And advantages of sheet files are it can be recyclable and reusable. So whereas load bearing friction files cannot be reusable. So these have long life both in above or below water. So it adapted in marine structures. These are cost effective and can installed without sound. These are available in wide range of length, size and steel options. And figure shows that is sheet files. Images, sheet files driven into seashores to protect inside materials from sea waves. It acts as a retaining wall. It acts as a retaining wall. So next is the fender files. Fender files protect the bearing shift from damage and it protect concrete duct or other waterfront structures from impact caused by ship. Fender files are generally made of timber. And figure shows the fender files and different types of files, that means sheet files, batter files, fender files and also anchor files. It has shown in figure. Okay, so these files will be provided in subsoil. And next, anchor files. Anchor files are provided anchorage against horizontal pulls and trusses. The process of fashioning a joist or joist girder to the masonry. And the process of fashioning a joist or joist girder to the masonry concrete or steel supported by either that is bolts or welded connections. So figure shows the anchor files. And next, batter files. These files are driven at some inclinations. The inclination of batter files generally varies from 1 in 6 to 1 in 2.5 slopes. Slope will be provided. These are used to resist large horizontal or inclined force. Such type of files are used for bridge, piers, retaining walls and abutments, etc. Okay, so abutment means that is the end support of the bridge. And batter piles. Figure shows the batter files it is provided. And next is the batter files. So that is it shows the ground level. So that is below it is substructures and water level for providing the that is the slab, and all the files will be shown. Sheet files, batter files and fender files, anchor files will be shown in figure. And next, compaction files. It is used to compact loose granular soil in order to increase their bearing capacity. Compaction files themselves do not carry any load. And next, screw files. Screw files consisting of a hollow cast iron or steel cylinders with one or more blades at the bottom. The blades are generally made of cast iron. The bottom end of the screw files with a blunt point is useful when the ground to be penetrated consisting of soil, that is clay or sand. So figure shows the screw files. And next, based on the material and compositions, concrete files, that is timber files, sheet files, sand files and composite files. So, or based on the materials, it is classified. Okay, and so based on materials used for the file, it is classified into cement concrete files, timber files, steel file and composite files. So based on the materials and compositions, it is the composition of soil do not carry any load. Compaction soil do not carry any load. So there are used to compact loose granular soil in order to increase the bearing capacity. In these files are driven to ground when that is thin file driven in soil. Soil around to more outward and make soil again loose and increase its density. So these increases density increases the bearing capacity of the soil. So files will be class, that is based on the materials. The concrete files means RCC files are the most common type of file used all over the world. Concrete files can be either cast in sheet piles, in which concrete is cast at the construction site, and in precast files, so which are manufactured under, that is conditions in predetermined sites and strength. And timber files. So timber files are cheapest type of files, but they have smaller load capacity compared to other files. Sheet files are used to carry heavy load, that is especially of steel files. To increase the length can be done easily. That is composite files, that means it is made up of concrete, steel, timber. So these are the combination of these is called as a composite files. And for example, some portion of the timber files are ground water level, so that is likely to suffer from decay due to the termites or any other decayed problem, by replaced by concrete. Similarly, the portion of the sheet files within the corrosion material, that is the environment, can be covered with the concrete for protective material. Plastic files are used in special applications such as in marine environment, so within the soil zones exposed to seasonal changes. So these are classified based on the materials. And next, so multiple choice questions. First question, the types of file which is driven at an inclination to resist inclined force is known as dash. First option, friction files. Second one, sheet files. Third one is the batter files. Fourth one is the anchor files. Any guess? Batter file is the answer. File foundation is generally provided if soil is dash compressible, waterlogged, made up, all the above. The answer is all the above. The files which support the load due to friction between the file face and surrounding soil is known as dash. Bearing files, friction files, sheet file, battered file. So answer is friction file. So next, fourth question, the file which supports the load partly by friction and partly by resisting on hard strata is called dash. Friction file, bearing files, friction bearing files, rough file. Answer is friction bearing files. File foundations are suitable for dash waterlogged soil, soft rock, compact soil, multi-storied buildings. None of these. Answer is waterlogged soils. Files are usually not made of steel, stainless steel, timber, RCC. Answer is stainless steel. So next. So last question. The files that are used to protect structures from ship or floating object is dash. Anchor files, compaction files, fender files, batter files. So answer is fender files. So next, application level questions. What is the difference between bearing files and friction files? And classify the various types of files based on functions, material, compositions, and explain the situations in which file foundation is preferred. Okay, once again I repeat. Applications questions. What is difference between bearing files and friction files? And next, classify the various types of files based on function, material and composition. Explain the situations in which file foundation is preferred. So these are the applications level questions. Okay. So next. So once again I recall, so foundations and types of foundations. So generally foundation, it is a structure constructed below the substructures. Okay, and the above the structure constructed above the foundation, it is called as a superstructures. The structure constructed below the ground substructure, above the ground it is a superstructures. And foundation is further classified into two types. So first one is the shallow foundation, second one is the deep foundations. Okay, and in shallow foundations, so already I told the depth of foundation is equal to or that is less than the width. And so in case of the depth of foundation equal or less than width of foundation, it is called as a shallow foundation. In case of deep foundations, the depth of foundation is greater than 3 times the width of foundations. So it is called as a deep foundations. In case of deep foundations, we classified into further two types. So first one is the file foundation, second one is the well foundations. Okay, and in deep foundations, in file foundations, so file foundations are classified on the basis of function, materials and also compositions. So on the basis it is classified. Okay, and finally the file foundations is preferred. So generally the important structures, we have to prefer the file foundations. Okay, so in the unimportant structures we preferred that is on timber foundations. Okay, and the files can be, it is file foundations can be classified on the basis of functions and materials and also compositions. Okay, and so finally we conclude that the soil, the main for construction important structures we preferred steel files will be preferred. Okay, and next so last, thank you.